My name is Hoelzle. I'm the Vice President of Operations here. And I'm really very, very happy that you all could make it here. I'm also very honored that you trusted us enough to come on April 1st. And I promise that this is not a joke. We're going to have a great program with lots of action. We have videos. We have a number of details. We have really top quality people here to talk to us from Green Grid and EPA, and then also in a panel discussion. So I'm pretty sure it's going to be worth the time that you're investing in this. Before we start, I'd like to just make a few remarks. First, why are we doing this? And the answer is actually very simple. We have been working for a while on efficiency in data centers for commercial reasons, and we have a great interest in moving the industry as a whole towards more efficient data centers. And many of you in the audience have actually been part of that effort. And so we're very happy to have today representatives from the Green Grid and from the EPA, two of the more influential organizations that have really moved the needle in terms of how we evaluate and design and optimize on data centers. So I'm very glad that you could all join us here. This is intended to be not a one-way presentation, but really we encourage active participation. There's a microphone for questions. Please hold your questions for after the talks. So after each talk, there should be room for 10 or 15 minutes of Q&A. So please don't be shy and go up and ask questions. We're videotaping this event. So if the feds are looking for you or so, stay away from the cameras. But otherwise, we're planning to post the full materials, the slides on the web by Monday. So you don't need to write down the details or so. You're gonna have access to these slides on the web. So before starting, I'd like to recognize the many folks that have actually made this event possible. A whole lot of work went into the event itself, and then a whole lot of work went into much work sort of leading up to it. First of all, I'd like to thank Aitan and Nikki. Are you here? No, they're still out there. Sheikha, who can, by the way, if you have any questions, if you want to reach anyone today, they can help you get connected to any one of the speakers or so. Small enough so you should find us, but just in case. They did a tremendous job in setting this up, inviting the right people, of course, namely you. I'd like to also thank our speakers and panelists from the outside for taking the time to come here, and I'm looking forward to their thoughts on this very important topic here. Namely, John Tuccillo from Green Grid and Andrew Fanara. Andrew, I haven't seen you yet, but I think you're here. Yes, all right, over there. From the EPA. Jimmy Cladaris, Chris Malone, and Joe Cava from our data center team. Ben Jai from our platforms engineering team, and Bill Weil, our green energy czar. You're going to see them all in the various presentations, but we're also mixing it up with really key insights from leaders in the industry as well. I'd also like to thank DLB and Don Beatty. I think I saw him in the back, who's been with us for much of the way in this effort. And then really the groups at Google too, who have worked probably for the past 6 years on various aspects of this, and I'm very happy that today we get a chance to show off at least some of the things that we've accomplished. So there, in particular, I'd like to mention in no particular order our platforms engineering group that does our servers and racks and the overall hardware, data center R&D and engineering teams who actually design and implement and engineer these facilities. The data center ops and hardware ops facilities who run the buildings and the servers and have been very, very good at working with us on various prototypes and being there when things don't quite work. We're not going to show you any of that today. And then the green energy team here at Google, who has been working on energy issues really for a very long time and has helped us also think through various issues in the data center world. So with that, I'd like to introduce John Tuccillo, who joined us here. He's a VP at APC and also was one of the early people at the Green Grid. And he's going to tell us more today about the Green Grid, what you're doing today, and your future plans. So John, please welcome John. So
Thanks,
now
Urs.
I need to find your presentation. Jimmy, where did you put the...
Right here, John Tuccillo.
Okay. All right.
The latest in voice-activated computing. I was joking a little bit earlier. I said if there's a technical problem, I can do hand puppets, soft shoes, and for a moment there I thought we were going to April Fools. Hi everybody, I'm John. I'm John Tuccillo, and I got to admit, it's awfully nice to be able to look around the crowd and recognizing so many friends, peers, members of the Green Grid, former colleagues, current colleagues. Google's assembled a really powerful crowd here. Hey, hi Ken. I see Ken there in the back. Paul Marcoux. It's a good group of folks. I'm glad to be here. For those of you who may not be as familiar with the Green Grid, I'm going to spend a few moments in the beginning of the presentation just to give you the very quick snapshot as to who we are, where we're going, some of the work that we've done. I'm going to focus a majority of the conversation today around some of the work we've done specifically around metrics and some new work that is being released. Actually, today's April 1st. So within this month, some new work that is going to be made publicly available. Just real quickly, if you look at kind of the challenge that we face as an industry, I look at how things are kind of out of whack. I mean, we've all been down this road before, but to set the stage, at the same time that our global economies are becoming more reliant on IT, we're hit with constraints that we had not been forced to consider before. They are things such as the availability of power, the cost of power. It could be capital expenditures. It could be those ever-expanding IT budgets that we all get to enjoy and flourish in. There's a variety of constraints that we're faced with at the same time that very logically, the business rationale for IT, the business rationale for data centers continues to expand. Things are a little bit out of whack. So what we do within the Green Grid is we're looking for ways to try to help establish more balance, more symmetries. How is it that this increased reliance upon data centers, technologies, infrastructures, and capabilities can be more in sync with the availability of power? Obviously, the more you do with less starts to define efficiencies. And that starts to get us a little bit towards the data center charter of the Green Grid. If you look at how the Green Grid has structured ourselves, we're structured across three core committees. Within the technology committee, this is how we get the work done. The technology committee is structured by these four working groups. So excuse the non-engineering interpretation of our working groups. Data collection and analysis. This is the group that starts to cast the net out wide. This is where we start to look at other associations. This is where we look at other standards work. This is where we look at government projects and we say, okay, we don't need to create everything here. Where might there be opportunities, research, and data that can support the argument for improving energy efficiency in a data center? And then how can we put it through the Green Grid process to help to validate that material, challenge where appropriately, but in the end up with a better solution for all of us? That's data collection and analysis. Data center technology and strategy. This is where the whiz-bang cool technologies get to be played with. This is where we have a group of technologists, and I saw Dr. Mike is in the room from Intel. Mike actually helps quite a bit in this particular working group, where Mike starts to lead this effort, where we look at some of the technologies out there and then validate as to whether this makes sense as being a very practical way to help make some quick improvements in data center efficiencies. And if they're not more practical and immediate, how might we be able to challenge and figure this out later for what I kind of call the Fred McMurrays of the group? All right, how many of you guys remember my three sons? All right, Fred McMurray. Well, I'm not quite sure I want to go there yet. Well, that's data center operations. So where Mike's team is coming out with the whiz-bang cool things like the flux capacitor from the DeLorean, is Fred, who stands up and says, I like the concept, but we can't practically employ it quite yet. And I'm going to walk you through some of the new things that are coming out of the operations working group. Data center metrics and measurements. It's what you folks who may not be active within the green grid, and I'll get your names after class. This is the group that has been out in the press quite a bit. These are the groups of people who are looking at different methods and methodologies for being able to measure, quantify metrics and measurements for data center energy efficiency. Spot quiz, has anybody in the room not heard of PUE and DCIE? Big improvement over last year. And I'm going to walk you through some of that material as well. So there's tremendous progress going on here. These four groups, one of the real strengths of the green grid, quite honestly, I think is in the way that we pull together these people with a methodology and a process to work together. Every member of the green grid has the same one vote. So you could be a real small company like our members at Google, at eBay, or you could be a mom and pop shop, kind of like a consultancy, but everybody has that same opportunity for that one vote. Everybody has the opportunity to contribute intellectual capital to the problem, where appropriate, and then go through a method of balloting and feedbacks across their peers prior to the green grid advocating anything. So the work that you've heard coming through the press has all gone through that process. I don't want to take a lot of time on it. If folks want to understand more about the process and how it works, I'd be happy to engage. There's also a number of Green Grid members here in the crowd, and I'll point you in those directions. Who are the founding members of the Green Grid? Who got together just over 2 years ago to start to pull this process together? But really what I'd like to take a moment to reflect upon is who we are today. As you saw on the last slide, there was primarily IT vendors were behind the creation of the Green Grid. Today, we've got a pretty healthy cross-section of constituents from the industry working on this problem under our process together. Today, our membership is just about 15% in the end user community. I'm going to spend a little bit more time talking about some of the work we're doing there. But you also start to take a look at the consultancies. We have utilities that are members. The intention here is to make sure that we're trying to get as much of a cross-section of inputs on the work that we're doing as possible. Real quickly, 2008 deliverables. This is a sample of some of the 10 or so white papers that the Green Grid produced last year. These are publicly available on our website. There's three core tenets to our charter. One, we come up with methods, tools, and processes to improve data center efficiency. Two, we work together as a group to then be able to make improvements across those baselines. And three, we share everything we do. We are a global nonprofit. Everything we work on, we share with the industry at large. These are samples of some of the 2008 white papers that are available publicly. You can download them, use them, challenge amongst the peers. We also have a number of new projects that are underway already. Some have already been completed in 2009. Looking forward, there's a big basket of work for us to take on here. So we started to segment it by these four core groups: metrics, tools, training, and ongoing collaborative activities. I'm going to spend most of the conversation and the time we have around metrics. I will lightly touch upon the other three. If anybody wants to talk more about them, we're available. Metrics, kind of the setup slide, but based on the caliber of the folks in the room, and I mean, we know each other pretty well, we all know why we need to measure. You can't improve what you can't measure. You can't address or manage that which you can't improve. So if you can't measure it, you can't improve it. We are taking on metrics from a way to establish that baseline understanding, those baseline metrics, and then where to make the improvements beyond that. And so since you all passed that first part of the quiz, I know that you're all familiar with PUE and DCIE. But it's important to note, a lot of people think, hey, Green Grid, you published PUE and DCIE. Great, that's a nice way to start. What's next? We recognize that. We look at this as just being one of what will be required as many metrics as we move this forward. One of the things that was introduced a year ago, February, was a concept around data center productivity called DCP or DCEP based on the paper. I'm going to give you a little bit more details and updates on that. PUE and DCIE, what are they? What are they not? What is PUE and DCIE? Essentially, it provides any end user with the ability to be able to take a quick snapshot of what their energy efficiency is more from a facilities perspective within their data center. What was it not intended to be? It was never intended to be a competition, though some competition is good and it's healthy. We all tend to make improvements there. It was purely intended to be able to give folks a baseline of which they can make their own year over year, quarter over quarter, month over month, SLA over SLA type improvements on their applications. The financial aspects of improvements in your measurements and metrics. So take this hypothetical as an example. Take an assumption of a data center that you've got a 5 megawatt load. Your cost is about 10 cents per kilowatt hour. Initially, you do a PUE review, and I'll walk you through some of the details around where to measure, how to measure, what to be included in the measurement. But say you ended up with a PUE of 2.0. Again, you're purchasing 10 now megawatts of power. Your cost is $8.8 million based on those assumptions. A little tweak to a 1, depending on the size of the data center, I don't know how little that tweak could be, but you got a 1.4 PUE now, and you start to realize a savings of $2.7 million. All of us in the room look at this, and we kind of take that as a, okay, we get it, that's an understood. So why do we get into this when we're presenting to a group? We think it's important that we as the data center and IT professionals begin to quantify the story. Now this is a simple one. This is a really high level one. But start to quantify this story for the CFOs, the financial suites of the end user community, so that you can now start to quantify ways that you can have a return on these efforts. Not every end user company has a dedicated effort today, not yet anyway, for making improvements in energy efficiency in the data center. Many do, but not all. So one of the things that we've learned, and this is by a paper that was championed by Dr. Ken Ullman of Eaton, who happens to be another member of the Green Grid, on cultural shifts that we need to make. How do we get the rest of the stakeholders in this space to understand the importance and benefit of improving energy efficiency? So this is just one quick version of how to do that. Something that was introduced in February at our tech summit here in San Jose. The Green Grid recognizes that it's important if we can provide reporting guidelines as to how folks are reporting their PUE and their DCIE. True story. Christian Bellotti and I were giving a presentation at a conference, maybe 6 months ago, on PUE and DCI very specifically. A very excited gentleman came to us from the crowd after the presentation, and he said, I got to show you this report I just generated. I'm a consultant. I really buy into what you're trying to do for measurements and metrics, PUE, DCIE, I get it. I now have based this into my business model, and I'm out trying to do these energy assessments. Okay, my little hair started to get a little nervous. He said, I got to show you, my client has a 0.8 PUE. Yeah, it's not exactly. The flux capacitor is plugged in the back. But there's some unintended consequences that are going on out there. And I don't think it's through malicious intent. I think it's because people don't understand. So one of the things that we did within the Green Grid is we kicked off an effort across the membership on putting together reporting guidelines. What do we think is the most sensible way to quantify the measurements that you're taking, and how do you recognize that? It's important to note, so let me kind of take this question off the table before a hand goes up. The Green Grid does not intend to go out and do data center energy assessments. We don't. It's not in our charter. It's not what we do. What we're trying to do is create tools of which a fairly well-represented industry is now starting to say, hey guys, we think this makes sense, and here's your baseline. So we're working, and I'll talk a little bit more about the collaborative efforts with governments around the world, here in the United States, DOE and EPA and others, to say, okay, as an industry, we think this makes sense. Let's challenge it amongst ourselves and help make it happen. But we are not, so I'll underline, we have no intention of doing energy assessments. And there's a common question I get hit with, so I wanted to make sure I took that off the table. This white paper, the PUE DCIE reporting guidelines paper, is being released to the public, I was told today, but since I haven't been personally on the website, I don't want to assure that, but it will be shortly. This was introduced and made available to our membership in February. We do that initially so as we continue to create member value, but also it gives one last gate for membership to be able to respond to us. Did we miss something? Did we overstate something? Should we challenge ourselves differently? It's a part of our process. The reporting guidelines white paper is being made publicly available, and I'll walk you through some of the details. If you take a look at just groupings of how to measure for PUE within a data center, I'm going to kind of keep it simple for brevity's sake. What we've recommended in here is let's have 3 basic levels as to the, how are you quantifying that? Are you measuring at the UPS? Are you measuring at the PDU? Are you really getting great and granular down to the U level? Here we're talking about server storage device routers. Anything is tapped in from an IT perspective. So you start to, those of you who have been working with PUE and DCIE, you can start to see how this starts to add some granularity. So that if you have one company saying, I've got a PUE of 1.2, I measured it one time at the UPS, R&I grand. Well, I'm glad they're looking. It's a good thing to do. But we have to also make sure that these folks are taking a look at the entire picture. So some of the other things that we've based into this are ways to take a look at how frequently are you measuring? Again, at what level of granularity are you measuring? Over what type of environmental conditions are you measuring? This project was created and staffed by a pretty healthy cross-section of folks from within the industry. John Haas of Intel, Dan Azevedo of Symantec, a number of folks from our newly emerging and rapidly gaining involvement and user community. And what we did is we spoke to these folks in terms of the pragmatic operations of your data center and where did it make sense. So just to cite a couple of examples, let me take it's a fairly granular one. Let's take a look at the 1.8 PUE. Just in following this, it was L2. Anybody remember the last slide? Where was that measurement being taken? PDU, right. So we know that they've been measuring this at the PDU. W, they're measuring it weekly. And they are doing a continuous monitoring at the meter. They may not just be recording it on a nonstop basis, but it is being continuously recording. Anyone want to take a guess as to why that's got value? So that if there was a spike in the particular data throughput at a given time, so that the demands on the IT infrastructure went up significantly, we can measure that against were there unique circumstances that led to that. Was there something that changed in the business model? Was there something that changed in the facility models? What changed that drove that spike? And it gives them the ability to be able to go back and take a look. One of the things that folks have been asking the Green Grid to do for a year, and we're being really careful not to go too far down this pike, is that I want to be a Green Grid certified data center. We don't do that. We're not going to go out and assess you. But what we do want to do is be able to offer some guidelines as to what kind of makes sense. This particular project was championed by the head of data center operations for Symantec, and then he validated this throughout the rest of the Green Grid. So if somebody's reporting a PUE, we're kind of saying, well, I'm glad you're looking, but we can't really recognize it by any shape, form, or fashion because we don't know if you're following our recommendations on where to measure, what to measure, how to measure, what to include in your measurement. And that's White Paper 14 for those of you who are taking notes. White Paper 14 really drills into that checklist, if you will. So, but if they're at least recording their energy efficiency, great, we're glad for it. 2, reported means that they're following the guidelines that we've offered, which is White Paper 14. It's going to have things such as the granularity in the reporting that I've just shared with you. Registered. One of the things that we've offered to do is to create an HTML site so that you could then log in your metrics following Paper 14 and the reporting guidelines, so we can send back some kind of correspondence saying, yeah, we can say that you did follow the process, you did follow the registration ideas, everything's right. So we're going to say, congratulations. So if you're saying I've got a PUE of X, we can somewhat assemble that, yeah, we'd stand behind that. But here's where it gets really important. I think where you really gain credibility is if you have an independent third party actually do the measurement for you, actually audit it. So if you are a end-use data center and you have hired an independent third party from any of the variety of service bureaus that are out there, say, okay, I followed the rules, I followed 14, I followed the reporting guidelines, and this independent guy just validated it and can certify that, yes, I do have this PUE. So it's simply a way to say, okay, now we understand that we're really looking at an apples-to-apples comparison. Oh, look at that. Marketing guys. I love that. So it's a way for intended results to be accurately and fairly reported. One of the things that the Green Grid kicked off a year ago is a database structure that would allow for us to start to take a look at how do you start to quantify data centers by type, okay, that's an open-ended one right there, size, Applications, what type of data center? What's your business model work based on? What kind of power topologies are you using? Are you in an area of the country or of the world that would allow for free air cooling? And we've got a database structure we've kicked off to be able to do that with the intent of just being able to share this. Remember, nonprofit, 501c, we give away everything we do. So it's not as though this is a revenue generating model for the green grid. We're producing these things across the membership to be able to give it back to the industry. DCP, the concept paper I mentioned last year, this is really exciting stuff. Data center productivity is kind of like the panacea. How do we know that we're actually being productive? Now let me ask you a question. Are we talking about data center productivity or useful work? Big difference. Easily confused. Data center productivity meant how productive is the data center against what the business intention of that facility and infrastructure of IT gear was. Useful work is what's the value I'm getting in the end. This actually proved to be something of a language issue that we've been working with other governments and cultures around the world to make sure that we understand that difference. But DCP was a concept paper introduced a year ago, February. It has proven to be very effective. It is also very challenging. The mathematics that are behind this thing are very difficult. It takes it to a granular level that many data centers, quite frankly, are not prepared to take on today. So what we've done is we've challenged ourselves. Through a relationship, through our collaborative efforts we have with PNNL, the Pacific Northwest National Laboratories, we gave them everything, just gave it to them, and said, well, can you guys please challenge this? Are we on the right path? Are we barking up the right tree? If not, let us know and we'll make some changes. For those of you from the HPC community, you probably saw the presentation PNNL gave, I think it was in January, where they reported their findings. They've validated that DCEP is a good way to go. In fact, they're so excited about it, they've started to move into the next generation of testing. But we said, hey, hang on a sec. Not everybody in the country, particularly in our community, is all working on high-performance computing applications. So let's start to instrument more commonly used applications and challenge ourselves again. That's currently underway. So we recognize that this is a valid way to go, but we also understand that it may not be available for everybody. So just last February, we introduced something we're calling the proxies. Think CNN. Do you remember the presidential debates and you saw those lines going across the bottom of the screen as people were responding to what the candidates were saying? Think about things such as the Dow Jones Industrial Average. Think about things that we look at as an aggregate kind of, yeah, that looks about right. We think it's going in that direction. And that's essentially what the intent behind the proxies was. In February, we introduced 8 proxies that we developed throughout our collaborative efforts with other entities around the world and then challenged within our own community, and have now made this publicly available out on the website. The intention here is that we're asking you. These are 8 proxies based on 8 similar yet different principles, and we're asking the industry to say, what works for you? Okay, these are 8 that we think make sense, but let's get your feedback. We may end up coming up with a proxy that is maybe a kludge of a couple, or maybe one of them really stands out. So this was publicly launched the first week in February. I think the last week of April is when it closes. Then it goes back into, remember the process? Goes back into data collection analysis. We'll probably go right to measurements and metrics. But because of the way we're structured, Mike's group within technology, as well as the operations folks, all have the opportunity to chime in. So that's the proxies. Again, we recognize that the metrics that have already been released are not the end all. This is something that was introduced earlier, late last year, called the Data Center Productivity Indicator. Okay, it's a spider graph. But if you think about how you might be able to use this in a data center, this gives you some certain degrees of flexibility. This particular paper talked about, as you look at an individual data center, or as I like to say, maybe you don't start there. Maybe you go look at one particular zone of the data center. And maybe you look at one particular type of a business application you're running within that zone. And it gives you a little bit more granularity so you can start to identify what your targets are versus what reality is, and ways that you can start to make some improvements. In this particular example, as represented in the white paper, we talk about it in very broad terms applicable to the data center. So what's your DCIE PUE? What's your target? And what, by following the actual white paper 14 and some of the measurement methodologies, in this case, their target was 90% DCIE. But their peak was actually 55, and their average was about 40. And this is just an example to show you then how very simple interface you can get a quick snapshot perspective as to where you are. One of the other spines here, we talk about server. Nope, this one's storage utilization. We talk about network utilization, server utilization, each one warranted by metrics and applicabilities to be able to measure, monitor, and report on. The idea behind the indicator is to simply give you a perspective as to, okay, here's what I want to get to. Here's kind of where I am. We also find that these kinds of simple graphic interfaces make it really easy to communicate with our peers. So if you did have to go to the CFO and talk about how you're doing and why you're doing and give them a quick perspective, here's the way to do it. If you want to have that conversation with your business partner, you may have someone who owns, let me put it in some simple terms, whoever is responsible for the HR applications in my company. They come to me and say, hey, I want to go buy this new whiz-bang new application, and I also want to have it on my own dedicated servers. We've never heard that before. So go buy it. And I can go back and say, well, I'll buy it. It makes sense. It fits our doctrine. It fits what our requirements are. But you know what? I don't need to keep that on its own server because of this. All this is meant to be is a simple communications tool. This is something that was launched in February, first week in February, the Green Grid Data Center Design Guide. This starts to get us into the realm where leaving metrics going to tools. One of the most common questions we get hit with is like, okay, great, Green Grid, you're doing some nice things, you got some great white papers and what have you. Show me how to build a data center. You're telling me you guys know how to do it? You got this great cross-section of membership? Show me how. So this is a project that was kicked off, as I said, in February. We have folks from within the end user community that are serving in management and chairmanship and vice chairmanship roles on this, working side by side with folks within utilities and within the IT vendor community. How are we structuring this effort? Well, we kind of look at it the way a data center works, but with a twist. You look at your typical facilities aspects of the building of the data center. This could be some folks that are involved in your building management systems. As you start to look more granularly into the data center itself, you start to look at your power, your cooling. Across the bottom, here's where the IT realm comes into play. But this hub and spoke design is intentional. What you have here at the center of this is what we're calling the management infrastructure and its related applications. This is where we start to look at the protocols and the ecosystem, excuse the pun, as to how all this will communicate with each other and at what level of granularity will it communicate with each other. So, for example, if I want my power and cooling equipment to be able to correspond with the IT infrastructure, the intention there is I start to level that balance. Remember the beginning of the presentation? So I start to now utilize the power and cooling that's required for my IT. Now here's where it gets down into the buckets. Are we talking about transactional throughput? Are we talking about bandwidth? Are we talking about storage? So this is where we start to build out some of those other aspects. I'm going to share with you some of the work that we're doing with through our collaborative efforts, but one of which to recognize, is DMTF. And I know Winston's here in the room, and this is one, thanks Winston, this is one of the projects we're doing with DMTF, with their SIM protocols, and challenging ourselves as a community. It's like, how do we know this is the right way to go? DMTF has done some tremendous work in this area. So we have a project underway with DMTF, and I'll walk you through some of the others. The tenets of the design guide. These are the 6 basic high-level rules we're using in the creation of the design guide. It has to be fully instrumented. How else are you going to know? It has to be fully announced. Follow some standard metrics. Be scalable, because the intention is to have not only a data center that could be a large enterprise class, you may have a small mom and pop. It's scalable. It needs to also be able to apply to a greenfield versus a brownfield. It's meant to be a design guide. Notice I didn't say it's a spec book. So you're not going to have in here certified products. It's meant to be a design guide. The intention is to launch the first version of this in February 2011 and then make iterative improvements year over year based on new learnings. Remember the flux capacitor guys. They're gathering new things all the time. I mentioned earlier Dr. Ullman's work around cultural issues. Ken, I know, has done an awful lot of work on some of the cultural barriers. I'll never forget one of the first presentations I saw was on an Uptime Institute presentation around something Ken called ICE. And it starts to take into account what the requirements are for just improving the community, improving the business practices, and working together. So we're recognizing that it's a combination of culture, process, and technology, thereby requiring year-over-year improvements. Other tools. This was launched in February. The power configuration tool. This tool is going to be made publicly available on our website this month. This tool allows an end user to start to plug in the varied power topologies they may be facing within a particular campus. They may, and oh, by the way, this is true. I've seen some data centers here in the United States, but most notably in Asia, that have varied power topologies inside their data center. So it allows them to plug in some of those values. But the intention here is that you can now go against this calculator and start to get a perspective as to what is your overall efficiency targets. Now it can get you back to that indicator tool. Something else that we've made available to the membership, this is being released publicly this month also, is a free cooling map. This first one is done for North America. We are currently developing free cooling maps for Europe. And there are 2 in the queue, one for China and one for Japan, and more to come. The intention behind this is the same thing. We want to be able to take a look at climate data and then offer to an end user to be able to plug in their particular values. What's your dry bulb temperature? Where are you located? What's your particular utility costs? So it starts to tell a data center owner and operator where there might be values that they can extract by using free air cooling. Again, this was released to the membership in February. It's going to be made publicly available this month. I wanted to say today, but I haven't myself logged on, so I don't want to give you the promise yet. PUE calculator, again, kind of brings us back to that earlier comment I made about folks are trying to do the right thing. I think that there are some unintended occurrences happening as a result of this. This is just a sample of the database schema that's behind it. The GUI is in development right now. This is going to be released to the membership this quarter, and then I'm hoping also within Q2 it gets to the public, but again, it's in the process that I described to you earlier. What you see here is there's actually 40 values that are based into this now, just for snapshot for presentation's sake. We're only representing a few here. This is a project that's currently underway with Mike's team, if I'm not mistaken, right, Mike? Yeah, this is within Mike's team. Training. No, that's not me, but we first had Christian Bellotti as our avatar there, for those you know Christian. The intention behind Green Grid Academy was that we launched, a series of white papers and tools. We're continuing to build on others. We recognized pretty quickly that, you know what, that's great, but it isn't really learning. What makes learning happen and become ingrained is it becomes more practical. So we launched in February to the membership something called Green Grid Academy. The intention behind Green Grid Academy and the first learning modules are all based on measurements and metrics. You walk into this virtual reality data center. Notice there isn't a company logo anywhere in there. And that was an interesting challenge, but it is a vendor-neutral, nondescript data center. This gentleman greets you as you walk into the data center with an introduction, say, "I'm glad you're here." It turns out to be Senior Vice President of Facilities, has a challenge that was brought about by the CFO, and here's basically what you need to do. Not uncommon for any data center folks to be able to walk into a data center and say, "Oh, something on high just said this is what you need to go do it because you're going to improve energy efficiency." This self-driven, intuitive system then allows you to select those modules of learning that you think you need to satisfy the challenge. And it's all based on the papers and materials that the Green Grid has already produced within our process. The intention here is that then you get to be able to plug in your own values against your learning, and it starts to make it more practical for you. It's fairly high level. Why? Because it's not intended to get into any of the nuances that can happen in any unique data center. But it is intended to offer guidance around some of the material. Measurements and metrics module is the first one to be released. Actually, today, the next module is being kicked off, and that was largely done with support from input that we received from our advisory council. Many of the members of the advisory council are here today. The fourth bucket, ongoing collaboration. I mentioned earlier DMTF. This is a sample of some of the formal relationships we have with entities around the world. I mentioned PNNL. Now LBNL is involved, and I saw Bill was here earlier. ITI, which is a group in Washington, DOE, EPA, the EU Commission, Dr. Paolo Bertulli, the Green IT Promotional Council from within Japan. So why are we doing this? It's because we're recognizing that there's great work being done elsewhere. So we don't have to create it. Let's figure out what makes sense and work with it. What you see across the bottom there is kind of a map as to how we start to overlay the direction we're going in and why, and some of the entities that we've identified, targeted. There is a long laundry list. It didn't sound very good, but there is a long list of folks that have approached the Green Grid saying, I've got a great idea, or I have this standards project underway. One of our biggest champions that we've been working with is ASHRAE. There's a number of members of ASHRAE here in the audience. We have a few projects underway there. But the intention is, again, to be able to look at the work that's being done, validate it, and figure out how to apply it. That particular committee is led by Jim Pappas of Intel. Jim's our chairman of the liaison committee, and he is one busy guy these days. The Advisory Council. The Advisory Council was actually created about 9 months ago, but formally announced only recently. The Advisory Council, and there are a number of folks from Advisory Council here. We have Olivier here in the audience. Anyone else from Advisory in the room? I don't think so, but Olivier is here from eBay. The intention of the Advisory Council was to create a check on the Green Grid. We wanted to create an entity that was going to have essentially the same authority as the Board of Directors to make sure that we stay focused on our charter. Are we barking up the right trees? Are we doing the right things? Are we approaching this from a perspective from the end user in the governance of the Green Grid? And are we taking on the right projects within the Technology Committee? And quite simply, if we're not, it creates a venue to be able to alter course. The Advisory Council is autonomous. We set up the Advisory Council so that if you are an IT vendor, you don't play. It's a way to try and keep Advisory Council pure to what the objectives are. Let me give you an example. Microsoft is one of the founding board member companies. They have a few data centers too. Google is a member of the Green Grid. They have a few data centers. Microsoft isn't counted in the end user community because of the products that they sell within the space. They can't be a member of the Advisory Council. What this does is it really starts to hone in on making sure we're doing the right things for the right reasons. TEPCO, Tokyo Electric Power Company, as a utility, Walt Disney Company, and others, they've held their first 2 meetings already and have provided some feedback to the Green Grid, and with the intention, okay, now here's the big close, getting back to the balance. We're hoping that through our charter, through our process, through the work that we've been doing, we're getting there. But here's the open solicitation. We want more help. We want more people to come to the table. The process does allow for a variety of ideas to be able to be considered and executed upon. Come join us. Come work with us. A good percentage of the room here, you folks are involved, and I thank you for it. We have a number of new members here in the room, and I thank you for that too. But it's an opportunity to work together as an industry to help to make these improvements. That's pretty much all I got. I know I went awfully fast. Thank you for the time. And I'd be happy to entertain a few questions. I think I've got a few minutes to be able to do that.
Thank you very much. Thanks. So we have time for questions. If you have a question, please come up to the microphone.
Come on, not that good. Paul Marcoux.
How you doing, John? Thanks for a great presentation. Really enjoyed it.
Thank you, Paul.
Really.
Thank you.
Truly.
Thank you.
Got a quick question.
Uh-huh.
We talked about, in one of your slides, you talked about networking, and basically the explanation is putting bits over your packets over watts, that kind of thing. Just to update you, by the way, that the ADIS organization this month has just approved the TEER methodology of measuring networks, and the final vote was taken yesterday, and it was ratified, so it'll become an official standard by the end of the month. That standard then is automatically transferred to ITU, which will also accept it as an official standard. The bottom line is this standard now takes not only bits over or packets over watts, but it also takes points in a network and other extraneous pieces of information.
That's great.
So it gives you even a more accurate
That'd be good to
measurement.
know. So guess who I'm going to put you in touch with pretty quickly.
Okay.
Now that's good to know. Thanks, Paul.
Thank you very much.
Thank you. That's good to know. Incidentally, that's one of the telecommunications industry has a few organizations that have developed standards over a long span of time. And we are in conversations with a few of those standards bodies now. Again, it's all part of the collaborative effort that we do. Yes, sir.
Hi there. My name is Kevin from eBay.
Hi, Kevin.
I have a couple questions. One is on the free cooling map. I hope, and it looks like you got it all right, but I wanted to see if that was based on a particular set point, or if it was just a wet bulb, dry bulb map of the United States, and you would let you select.
Yeah, I wasn't a part of the team specifically, but I do know that it allows you to be able to plug in not only your own values, but the Department of Energy has a database that they use, and I think the EPA has a database that they use for being able to keep an ongoing evaluation of these zones. And that was one of the bases used by our subcontractor to be able to plug those values. Hi, Mike.
Just to follow on to that.
Thanks.
The default is the ASHRAE recommendation, but you can put in
That's right.
any values that you would like to do a lot of what ifs.
Did everybody hear that from Mike Patterson? And also, I don't think I'm letting anything out of the bag here, is ASHRAE is now reevaluating some of those standards and values, particularly around humidity, and we're working with ASHRAE there too.
And the second question is, and it's probably already in the spec, but when you say continuous monitoring level for a DCIE or PUE measurement, what is the interval that is it 1 second, is it 1 minute, is it 5 minutes, is it 10 minutes?
Yes.
How continuous is it?
The paper actually talks about 15-minute increments, which kind of seem to be a pretty good average based on everybody that we spoke with. And that's just the way it's defined now. One of the things about the green grid is, and we've done this a few times already, we may publish material or tools or create set points for folks that we then get challenged and put it back into committee and say, hey, you know what? This person brought up a great idea. Let's put it back through the process, and we've made adjustments and republished things with updates. So if that changes, just like as Mike mentioned about some of the changes coming from ASHRAE, we absolutely embrace that, challenge it, and update the material. And that's true of pretty much everything that we do. Two good questions. Thank you. Anything else? Oh, gentleman coming up to the microphone.
My name's Oz Morales. I work for Amazon.com. A couple of questions along the same lines as the eBay fellow. Free air cooling map, are you guys thinking of expanding that to maybe include where humidity puts additional pressures on the thermal cycle? So essentially just a free cooling map, or we might be able to use evaporative cooling options. Number two, on your daily reading for your PUE, what time of day is that? Is that like midnight? In the Arctic, or
yeah, with the little generator with the hamster in the back of the room. Yeah. As far as the answer to your first question, Mike tells me that we are, but Mike's actually also serves within ASHRAE. So if you want to get into some details around where ASHRAE is going and how we plug these values in, Mike can help you for sure. But one of the things that we did do is we worked with ASHRAE in the creation of this baseline. So a lot of that material is there. As that changes, we'd build that in. Your question about is it midnight in the Arctic for PUE? The answer is sure or no. It depends on where the data throughput is occurring at the time. Many of us have been engaged in discussions around follow the moon. And can I start to move my transactions or my data center requirements around where power is inexpensive at a given time? And is the green grid developing things for that right now? No. But tools like this give you the opportunity to take a snapshot of where that transaction would be at a given time, so where you might be able to capitalize on that and thereby reduce your energy footprint, if you will.
Thanks.
You're welcome. I think,
Anyone else? Jimmy?
Hello,
Hi.
host.
Hi, John. How are you?
Well, thank you.
Good, good. You mentioned that you're not in the business of helping people measure. So
Not to do assessments.
assessments, okay.
All right.
So what kind of resources, or is there a coordination to make these resources, or people that are in that business
Yes.
to help operators?
Yes. Many of you in the room are familiar with the Department of Energy's initiatives around qualified energy assessments. This is something that was kicked off by EERE. But the intention here is that if the Department of Energy wants to be able to have a certain number of energy assessments done in a certain amount of time, you need to have first, what's your baseline? What is it that you're going to want to conduct as your minimum requirements for a DOE approved energy assessment? And then who is qualified to be able to do that. So they would go through a program, again, from the DOE to be able to certify how that would grow and how that would mature. So the Green Grid, ASHRAE, LBNL, other organizations are working together to say, okay, what are some of the things that this should look and feel like, and then be able to put that together as a method and a process. The value of having this gone through something like, for example, within the Green Grid is it gets challenged. ASHRAE has a similar process. LBNL certainly has the experience and capital to be able to add value to how to figure that out. But it's not the Green Grid's intention to be able to then take this and send out Green Grid energy assessors. The intention is to help to create that baseline understanding, requirement, and tool set of which folks that are then certified by DOE or other bodies around the world then have their toolbox to be able to execute. The Japanese government is looking to do some similar. The EU Commission is looking to do similar. So we work this all together.
Thank you.
You're welcome. He gets extra points for jogging to the microphone. Score!
Hi, my name is Will. I work here at Google. I have a comment. Early on in your presentation, you kind of made light of the person who came to you with a PUE of 0.8.
I'm not telling you who it was.
Fine. Although I'd like to know. I'd like to talk to that person. I'm just hoping that won't discourage people from looking in that direction.
That's a great point, Will.
I think less than 1 is very doable in the foreseeable future. I mean, that's the genesis of the flux capacitor. That's the motivation that we flux capacitor designers work with.
That's a fair point, but that would also take into account cogeneration. And the way PUE is structured today, it does not take into account cogeneration, but your point's taken for sure. All right, well, thanks very much for your attention. As you could probably tell, I can point to a variety of Green Grid members here in the audience. So if you need greater depth in any area that I'm certainly not skilled enough to be able to answer, I'll point you in the right direction. Thank you very much.
All right, thank you, John. It's really encouraging, I think, how much progress we've made and the Green Grid has made in terms of getting out the news and really helping people think about these topics. And while Ben is getting mic'd up, I'll give you just a brief preview of some more things to come. We try to really mix sort of contributions from our side with contributions on from the outside. We have 4 sessions that are done by outside people, 3 from Google. The first one is going to start. I'm just going to walk you, give away all the things very quickly before we start here. So we're going to see very soon how we do a 99.99% efficient UPS, and you can actually go and touch it. You'll see detailed PUE data. I can't really fully give it away, right, in fairness to people. You're going to see details of our design, right, with actual drawings and CAD. You're going to see a video tour of the outside and inside of a data center. And you're going to see even more dirt with videos on Google's data centers. And you're going to see, I think, what's going to be the highlight of the day with a chance to tour. So with that, I'd like to hand it over to Ben Jai, who's going to talk to Chris, who's going to talk, open the next session and talk with Ben about, what's really behind our PUE numbers.
Morning. My name's Chris Malone. I'm with Google's Data Center Research and Development Group. And this morning with Ben Jai, we're going to provide you with some insights into Google's PUE results. So let me begin by setting the stage, talking about what we've already disclosed. This is a chart from our external website where we've published PUE data for 6 Google data centers, Google designed data centers. And so the chart basically shows the energy-weighted quarterly average PUE results for these 6 data centers, and starting back in Q3 '07 to the last release of data was in Q4 '08. It's our practice now that upon qualification of the data center, all Google data centers that meet this criteria will be published quarterly. We'll do quarterly updates on PUE. The criteria for inclusion are 5 megawatts of IT power and an operation of 6 months or more at that power level. The intent there is to publish data for Google data centers that have reached some level of stabilization, right? When early days, data center operations are somewhat inefficient, but once we get past that commissioning stage, we're going to publish and continue to update regularly. So we did this announcement a couple times now. We provided a lot of details, but today we want to do even more than that. So we want to show you sort of more of the how we achieved these numbers. What you saw there were PUE results that were all less than 1.3, which are pretty good. So today we want to talk about the innovations and best practices behind those numbers, so how we achieved it, and also talk about measurement method and accuracy. So as John kind of went through in detail, the practice of categorizing and measuring data center efficiency is a relatively new art. Right? A few years ago, nobody had a clue what their data center efficiency was. So we've taken some time to investigate this, and we'd like to share our findings in that area. And next, kind of provide some insight and the benefits of measuring PUE on a fine-grained basis for all the facilities, how we use that for operations and design. And then I'll close that with an update, the latest results for these 6 data centers to present time, and a server on display. Underneath that sheet, we'll do a reveal and show you some real hardware. So let's start by looking at the typical industry PUE value relative to the typical Google data center PUE. So what I'm showing here is the impact of power and cooling best practices. That's sort of the theme of the day. On the left-hand side, we've got the typical PUE value of 2.0. This comes from the Silicon Valley Silicon Valley Leadership Group report from last summer that looked at the constituent components of a typical data center. So to review again, PUE is this measure of the total energy consumed by the data center divided by the IT power. So for the typical data center, PUE of 2 means that for every 1 watt of IT power, you're burning 1 watt in overhead just to keep the operations running. And the two culprits, 2 main offenders in terms of overhead are power required to run the cooling plant and the power losses associated with distributing power and maintaining the backup solution. And so let's dig in a little further here. So if you look at the comparison on the cooling side, the typical plant uses 0.7 of the PUE for running the cooling plant, and the contrast there for the Google site is 0.105. So that's an 85% reduction in the cooling energy. And then on the power distribution side, 0.22 versus 0.039, so roughly 4%. Right? That's an 82% reduction in those values. So addressing those 2 categories drives a substantial reduction in the overhead. But the real question is, that's great, but how did you do it? So the good news is we go through these things. Cooling energy down by 85%. We did that by the rigorous application of best practices. So underneath that sheet is not a liquid-cooled, sub-cooled Google server. These are standard air-cooled servers, standard technologies, and the application of these basic 3 categories of best practices are really what enabled these results on the cooling side. So close-coupled cooling, and what that means is essentially eliminate the mixing of hot and cold air streams and derive the maximum cooling benefit from your cooling resource. Raise the temperature, which is fairly intuitive. We raise the cold aisle temperature, and the efficiency of the plant goes up accordingly. And then third, economizers. So in both flavors, air side economizers or water side using cooling towers. The application of those 3 really unlock a lot of potential for energy savings, generally in the industry. So there'll be a lot more detail on how we've used these this afternoon in Jimmy Clidaris' talk. On the power side, that reduction of 82% is mostly achieved by the innovation that we've developed on the UPS side. So that's the main culprit in losses typically in data center power distribution is the UPS solution. We have a solution here that's delivered 99.9% efficiency. And so Ben Jai will come up here and talk about more details on what that means right now.
Thank you, Chris. Yes. Okay. Hi, my name is Ben Jai. I was in charge of Google's electronics design from 2003 to 2007. And this is one of the highlights we've achieved during that period of time. And we start by looking at a typical facility UPS design. And you have the grid AC coming in and going through this UPS with rectifier, battery, and inverter, the double conversion from AC to DC back to AC. Then you deliver it to the IT equipment. And the best you can achieve usually is around 92 to 95% because you don't run your system at full load. When you have an N+1 configuration, usually your load goes down and so is your efficiency. So what if we can just deliver the grid AC directly to the IT, then you get 100% efficiency. Yay! However, you will immediately see a problem. Hey, where's your backup? What if the grid AC goes down, right? So we actually did not set out to find a UPS solution from the beginning. Since I was working in EE electronics, we actually started by looking at the server itself. This is a typical PC. If you open the chassis, you'll see this big pile of wires coming out of the power supply and going into the motherboard with all the various colors indicating different voltages. And then you have a string of harness going to the disks to supply the power. One major problem with this design is most of the time the power supply designers don't know what the motherboard is going to want on each voltage rail, so they have to over-provision a lot on each rail. As a result, the power supply may be running at as low as 65% efficiency. We try very hard to tune these and got it up to 85% efficiency. However, we couldn't get it any higher without some drastically different design. So this is what we came up with. Since the motherboard knows what its components need, why don't we let the motherboard make the decision and just deliver a single 12-volt to the motherboard? This is actually just like any laptop computer, right? And then all the disks still need 5 volts. So let the motherboard decide how many disks it wants to supply to. So the power supply can be designed to fit exactly how much the machine is going to need, therefore very little wasted capacity. So we were able to get it up to 92% efficient in this case. And this is not even counted in PUE because this is inside the IT equipment. However, when we do DCP measurement, this is going to be counted. So this was actually announced a couple years ago in the Climate Savers Computing Initiative, and with the Gold Plus, 80 Plus Gold label. And also, with this design, it's very natural to think, okay, 12 volt, what does that correspond to? Hey, car battery. So what we end up with is, so our power engineers, one of them sitting here, came up with the brilliant idea, hey, why don't we just attach a car battery to this point? And then we can get very high efficiency. How? Well, first, you're going to see this. This is a real Google server, one of the first we built following this idea. You'll see the power supply on the left side and with the power cord, DC power cord to the motherboard, yellow, 12 volt, single voltage, and with the battery way over here for cooling purposes, and the disks attached to the motherboard instead of the power supply. So basically, this UPS design runs in 4 modes. Shut down, when you turn it on, it starts recharging. When it's full, it goes into float mode. And if you lose the AC, it goes into discharge. Then if you stay there for too long, we'll just shut down. If the AC comes back, go back to recharge, of course. And over 99% of the time over the life of the machine is spent in the float mode, because these are servers. They're not supposed to shut down. They're going to be running 7/24, right? 24/7. And here is a circuit diagram of the UPS unit in float mode. You have the supply coming out to the machine, and the battery basically is just floating on this voltage rail. The discharge transistors are actually connected at this time. Therefore, your battery voltage is equivalent to your power supply voltage. And in this case, the only power loss you sustain is the leakage, the self-discharge current of the battery. And following this simple calculation, you'll see we achieve 99.99% efficiency for this particular configuration. And of course, it all depends on the angle of the moon and the stars and so on, and if there are quasars bursting at the time. So we made a safe claim to say we're running above 99.9%. Okay. So what we have achieved here is, well, okay, first we didn't just set out to build a more efficient UPS. If we try to do that, we may be able to push the UPS all the way up to, say, 99%, but then suddenly we have to use an N+1 configuration, so it dropped down to like 80% load, so then there goes the capacity, efficiency. So we just kept our eyes open at all opportunities. We saw this server design and then said, hey, there's your UPS, so move it away from the centralized location in the facility. This saves both the CapEx and the OpEx. This solution is much cheaper than a huge centralized UPS, right? And we eliminated the double conversion. There's a big chunk of inefficiency in UPSs. And we use small batteries just enough to sustain the machine through the power trip. You don't really need to run the machine on batteries for 10, 20 minutes, right? You just need it for like 1 minute until your generator start up or your AC switch to a different grid and so on. And this also allows us to deploy the UPS incrementally. It comes with each machine, not just servers. We design our own networking gear, so the network switches also come with their built-in UPSs. This way, you don't need to do a very difficult decision at the beginning of your planning, like how much UPS capacity am I going to need in this facility? And therefore, no wasted capacity, okay? And the single voltage power supply is the enabler, and a lot of the server companies are actually doing single voltage servers these days. Well, actually, if you go back to a telco era, they do it all on 48 volts anyway, right? But then they have these huge capacitors. Okay, so we were able to actually measure our usage to greater than 99.99% efficiency. That concludes my segment of the presentation.
So yeah, there's no need to keep the cloth on anymore. So there'll be an opportunity at lunch to come up and have a look at this and ask questions. Okay, so Ben gave us some perspective on the UPS side, the innovations we drove into that part of the overhead problem to improve our efficiency. Now I'd like to take some time to dig into the details around how we did our measurements. Again, to reflect on what I said earlier, this is kind of a new area, and so we've made some attempts to standardize how we do things. We want to share that. So again, for review, not everybody in the audience talks about PUE every day. So I just want to refresh everybody on what the intent of the metric is. It's, again, the ratio of total facility power over IT energy. And the intent there is to isolate the overhead components from the actual power that matters, the IT power, right? So you can identify that clearly. The EPA put out a very valuable document back in the summer of 2007 with a lot of industry participation that characterized where the industry was going to be headed in terms of PUE over the next 5 years or so. And the projection sort of involved looking at today, in 2006, the classic PUE of 2.0 data center, which is still roughly true. And then how would that number improve as a function of the technology that you invest and put on the floor? And so the interesting observation is that the state-of-the-art number here was 1.2. And that involved the use of what we term exotic technologies that are not on this server, like liquid cooling directly to the server and so on. So remember that number, because we're going to talk later on about where we stand today in terms of our own PUE results. But this kind of gave a good perspective on the potential movement from where the industry was in 2006 to where we could be in 2011. So I'd like to talk a little bit about some of the Green Grid metrics and classification systems that they've developed around how to measure PUE, because they've been quite valuable in assessing how we're doing. This one comes from a report that John talked about in his presentation that classifies in 3 different tiers the accuracy of your measurement, right? So level 1, basic, level 2, intermediate, measuring at the PDUs, and level 3, advanced. And so just to frame up our numbers, I'd like to apply our Google assessment of our own accuracy. And it's complicated. We're tough graders, but we gave ourselves a 2+. So we lie somewhere between intermediate and advanced. And I'll talk about the implications of that and the associated accuracy of our measurements. But just to go through row by row what that means is instructive. So IT equipment power measured from, effectively we measure at the PDU. So to classify yourself as the level 3, measuring as in the spirit of the PUE right at the line cord of the IT equipment, we don't do that at present. We've enabled that on many of our new servers, and we have the access to that data, but we don't use it to calculate our PUE at this time. We could go there, but presently measuring at our PDUs and the way we do gets us a sufficient accuracy to characterize the efficiency. Total facility power measurement from, we classify that as level 3. We're able to distinctly measure all the overhead components and isolate them from extraneous power consumption. And in terms of minimal measurement interval, critically important topic, as was raised in the Q&A earlier. We're a mix. In the 6 data centers that we published, 2 of them we measure daily, and the other 4 we measure continuously and automatically. And that's our go-forward plan for all new facilities. We automatically measure on a continuous basis on the second granularity. I'll talk more about that later when I show some results. But to set the stage in terms of how we do our measurements, it's necessary to go back and look at how power flows through our data centers. So this is a simplified schematic that shows the power distribution scheme. And I'm going to walk you from left to right. So left being the AC power coming in from the utilities at high voltage, all the way to the right, which is the important stuff, the server, storage, and networking gear. And I've color-coded this for easy consumption. Green is the IT equipment, and red are all the other components between the utility and the servers, and they all have an associated efficiency, so they all have losses, essentially. That's an overhead component. So to kind of walk you how the electrons flow, we start at the substation, convert that to a medium voltage, and distribute that on a multiplicity of medium voltage switch gears. Those medium voltage switch gears distribute to what we call unit substations. And those are essentially 2 flavors. One set supplying overhead. So that's the, as I show in the picture here, cooling plant overhead, primarily 99% or so. And then the other flavor is the unit substation devoted to IT equipment. So that's almost purely driving IT load. So there's a conversion in the unit substation from medium voltage to low voltage, and that low voltage is directly distributed to the IT equipment on the data center floor. And you can see highlighted here is the UPS solution that Ben described in line with the servers. Okay, so that's the how, the layout of the system. Our measurement points are, in terms of PUE, are illustrated right here. Right on each of the unit substations, we have meters with high accuracy. I'll show that in a second, what that accuracy looks like. But just from a high level, again, to calculate PUE, we measure here at the unit substations. We extrapolate to the meter here at the utility to estimate the total power coming into your facility. And we extrapolate down to the servers from these unit substations. And the losses associated with those terms I'll cover next. But generally, they're extremely small and easily characterized. So simply put, to calculate PUE is approximately the sum of the power from all the unit substations, i.e. the total power coming in, minus some, plus some small terms to account for the losses from the substation back to the grid, divided by the IT unit substation power, minus some small terms to account for losses between this measurement point and the real IT gear. Okay, so the measurement points. We spent a lot of time thinking about where to instrument and how to instrument with pretty good accuracy. And so what we do here is we have a CT, a current transformer, a potential transformer, and a revenue grade meter with a calibrated accuracy of that whole circuit better than plus minus 2%, with a 3 sigma RSS value. So that's how we're doing all of our metering. As I said, 4 of the facilities, that's continuous. 2, it's a daily measurement. So that's sort of the measurement points. I want to take some time to walk you through the error analysis. In our public announcements, we've claimed an accuracy of better than 2% plus minus. And so I want to talk about how we did that. So the unit substation measurements themselves, the key to the measurements, we've assessed that accuracy at 10% of the total. So for this data center E, and I'll be talking about data center E throughout the course of the presentation, the energy weighted average PUE for the last 12 months is 1.16, and the error associated with that is 1%. So the unit substations account for only 10% of that error. Now, doing the extrapolation from this measurement point back to the grid, that accounts for only 2% of the total losses in the power consumption of the data center. And we've assigned conservative error bar of 13% of that total. And you can see we have a measurement point here. Part of the process we've gone through is to actually calibrate these losses. So even though we don't measure continuously in these points, we certainly have calibrated and we have high confidence in the values that we're reporting. So now the other components that need to be accounted for, just for absolute thoroughness, there's 3 other components here. So there's a small amount of networking gear that's powered from the overhead unit substation. Not all the networking gear, it runs off of the IT unit substation. It amounts to only 0.2% of the total power, so effectively negligible, and an associated error that's extremely small, and again, well calibrated with a meter in line here. On the other terms that matter, overhead. So there's actually crack units on the data center floors with fans, and we power those fans using that IT unit substation. So that accounts for 3% of the total power. So it's a pretty efficient air mover to circulate air in the data center. And we conservatively assigned error bars to that based on calibrations and testing, and it amounts to 73% of that 1% error term. And then finally, the interesting term here, one that we talk about a lot, are the losses between the, i.e. the PDU effectively, and the line cord of the servers. We've metered that. We've measured it many different ways. It amounts to only 1% loss and 5% of the error term. So that's kind of a walk around the measurement points for PUE. And to sum it up here, again, for this data center, this is reflective of all the data centers in our study. The error is about 1%, and that's 3 sigma RSS. The key point is there are estimated terms, but the magnitude of the power that they consume is really small relative to the total. And the accuracy that we assign to them is conservative, and the overall accuracy of the measurement is still pretty good. So 1% has been more than accurate enough for us, and so that's one of the reasons we're not so concerned at this time of going to measure directly at the line cord, although it is possible. Okay, so that's sort of the confidence intervals that we assign to our measurements. Now let me show you some PUE results. This is the chart I showed earlier with some additional commentary and green grid-ified measurement schemes. So what you see here is those 6 data centers. Again, we've classified these all as L2 readings, and we've assigned these ratings where we're reporting quarterly averages. We do energy weighting, so we account for the changes in IT load over time. And some we record daily, some we record continuously. So that kind of reflects what we think is a valuable way of categorizing or characterizing your measurements. Some of the commentary here, this was on the microsite from October and January. We saw an uptick in 2 of the newer data centers back in Q3. And this is partly a seasonal effect, right? As we move into the summertime, if you have evaporatively cooled data centers, you're going to see some impact of that, and also some commissioning effects. So we'll talk more about that and how we can view that in greater detail in a few slides. So this is the drama moment for my presentation. You see there's a missing quarter here. So what do you think? Is it going to go up or down? It's going down, right? If it didn't go down in the wintertime, we'd be in trouble. So this reflects the latest data as of March 15th. Our policies, we go through a whole auditing process at the end of the quarter, and we scrub the numbers and we publish them again. So we backed off by 2 weeks, and I didn't feel like doing all that this morning before this talk. So the net of it is, you can see nice graphical trends here. Everything's moving in the right direction. This reflects ongoing optimization. Some of these facilities are several years old, but we continue to invest in improving the efficiency of the plant and the IT equipment, and so that's reflected in the overall PUE, and of course the beneficial seasonal effects. So that's the graphical view is useful to get overall trends. There's many ways to cut this data, and I'm not going to walk through every number in this chart. Don't worry, but this is another way that we look at the data internally, and it's also the way we publish our information. So some of the numbers that are of general interest are the quarterly energy weighted average PUE, and so that's for all 6 data centers. How are you doing in the latest quarter? And the result to date here is 1.15. So we see continuous improvement from the initial release down to 1.15 today. The number that I think is probably the most useful in terms of judging the health of the entire fleet is this trailing 12-month energy-weighted average PUE. We call this, we focus on trailing 12-month because it's our practice to update every quarter, right? So we want to look back over the last 4 quarters, capture all the related weather effects, and essentially characterize the health of the data center in relatively recent terms, so we're not digging way, way back into the past. And the good news there is that when we first reported, we were at 1.21, down to 1.20, and then the latest result is 1.19. So just a little note here, you see an asterisk on this last result. And I know there are people out there that pay attention to these numbers. Sometimes they make magazine covers. The 1.21 from October, what we did was we did an audit recently and found that some of the power that we characterized as IT, small fraction again, more properly should have been accounted for as overhead. So when we did that audit, we actually changed the numbers. These are huge numbers, and they happen to round up to 1.2 instead of 1.19. And you see that a few times here. So that's our practice, is to go through this rigorous ongoing audit to account for all these energy flows and update accordingly. And so, not to bore you to death with all these numbers, but one final takeaway, one that gets most attention is, what's your best facility right now? And so the best facility to date right now in this last quarter is 1.12. Okay, so that's the data, and I said keep in mind those numbers from the EPA report earlier in the slide deck. So we've actually, as a as a fleet, the Google fleet, we've actually done better than the projection from the EPA report from the 2011 era fully advanced technology data center. So what's encouraging about this, right, is that we've achieved this now by the application of best practices and some innovations. Nothing really inaccessible to the rest of the market. So there's opportunity for the whole industry to lower their PUE dramatically. So let's look at another cut at the data. I mentioned that for 4 of the 6 data centers, we record in the sub-minute, in the second granularity, and we use that in different ways. And this is one way of presenting the information. For again, this candidate E, the data center E we keep talking about here. What I'm showing is the overhead for the past 12 months. And so if 1 plus this overhead is the daily PUE. This is averaged over time. And you see some interesting behaviors here, some spikiness, sometimes attributed to weather, right? So if in this part of the year, you see some days that go where it gets hot out and the chillers stay on longer, and you see a resultant spike. We'll talk more about that in a sec. But one of these things is kind of interesting. Back here in Q2 08, we saw this data center going from relatively stable operation to a sudden spike that lasted for a prolonged period of time. And this was the result of taking a data center floor, this E, that was relatively stable and expanding it. And to do that, we added in a second process chill water line. And so in the process of bringing that up, balancing and getting the chiller operation right, you saw this prolonged spike in PUE. So this is kind of interesting. These are the kind of tuning data points that you can actually gather by continuous measurement of PUE consumption. So to zoom in even further, same data center, but the time scale here now is the month of January, so 2009. And again, you see the stable operation and then a sudden blip. And January, typically you wouldn't expect in most places to see weather-related blips. It may be commissioning effect, whatever. We actually looked into this, looked at the wet bulb temperatures, and you saw an anomalous spike during this first week of January in this location that drove substantial, not so much, but 7% increase in PUE. And so what that meant is that essentially the chillers were running for longer periods of time during the operation. Sort of unexpected, but these are the things you can pick up. And then it pops right back down to this average. So this is showing hourly data. We can get even more fine-grained if that's needed. So for operational issues, you can look even closer. So these are the kind of things that you can pick up with this continuous metering. So a final cut at the data, right? This is yet another way of looking at PUE. What I'm showing here is PUE as a function of the percent load in the data center. So all data centers have a design load, and most data centers don't approach that design load ever. What I'm showing for the 6 data centers in the study is the basically a whole bunch of data points collected over time that reflect changing IT load or changing conditions. So obviously, as IT equipment is added or subtracted to the facility, you see the impact on the mechanical plant efficiency. Most data center mechanical plants don't scale linearly in terms of their power consumption. They have fixed power consumption elements in them. And if you were to bin this data based on constant temperatures, you may be able to see more of that. Another observation here is, the older facilities A, B, and so on have loads approaching 80%. E and F, as we showed earlier, those are the newer data centers, newer to the study. They're further down on the load curve. And we see this vertical spread, and that's attributable primarily to weather effects, to seasonal effects, and also to this plant scaling issue. If you're lightly loaded, you're going to be less efficient in terms of your plant. So another way of looking at the data for design decisions or for commissioning insights. So that's the PUE data to date. Expect more every quarter. just to conclude, a few points I want to make. If you reflect back to what I showed earlier, the two overhead culprits that we address most seriously are the cooling plant power consumption and the power distribution losses. And by application of best practices and innovations on the power side, we're able to reduce that by 80% or more. And the encouraging thing about this is, if you look at the UPS solution, 99.99, you name your number of nines, that's very efficient. But what's encouraging is there's a lot of solutions in the marketplace that approach that, within 2 or 3%. So that's an interesting avenue. It's a topic of a lot of discussion right now in the industry. But there's options out there. And then cooling best practices, the three that matter, closely coupled cooling, no mixing of the air streams, raising the temperature so as to improve the efficiency of the plant, and then the use of economizers, water side or air side. Those unlock huge savings, and those are accessible to anybody in the industry right now. So that's the point I'd like to leave you with, is the innovations that allowed us to break through the EPA predictions are mostly available generally. So that's encouraging. Just an update on our results. The trailing 12-month average has reduced quarter after quarter by 1% point. So we started at 1.21, down to 1.2, and now we're at 1.19. And the accuracy we assigned for that is, much better than 2%, plus or minus. The final thought here too is, as John said earlier, know your PUE. Start somewhere. Start measuring. Even if it's not a super high fidelity, it gives you a baseline to start moving forward and identifies opportunities for improvement. So, final parting thought, what's next? Where can we go with these efficiencies? And so the use of economizers, the essence behind that is to reduce your chiller operating hours, right? That's the best practice, minimize chiller operating hours. The best embodiment of that would be to eliminate the chillers altogether, just no load those. And so, the benefits of this are pretty straightforward. You reduce your capital costs, no spend on the chillers and the infrastructure to support the chillers. You reduce those PUE spikes, right, that we saw earlier, and now in fact they could baseline at some flat level and go low based on the weather rather than popping up above. And the targeted trailing 12-month average PUE result could approach or go below 1.1, right? We've achieved 1.12 with some of our facilities with chillers. So a reasonable target could be 1.1. And we have an actual experiment going on right now. It's a production data center environment in Belgium that's completely chillerless. So you can see a picture here, and it's hard to prove the lack of a chiller because we don't show pictures of it, but it's not in there. So we're eager to update in the future with results from this facility and others. And with that, I'm going to stop for today. Questions?
All right, we have about 10 minutes for questions, so please again use the microphones.
Yes, Paul Marco with Cisco. Thank you for sharing this. This is absolutely great data. I have basically two questions. One, I've noticed that within your presentation, there seems to be an absence of backup generators. Is that something that is standard within? Because normally if you use a generator, your PUE is negatively impacted. And my second question is, can you maybe elaborate a little bit on your management organization that delivers these kind of savings? Thank you.
So with the, I'll defer to Ors on the management side, but with the generator question, I radically simplified that distribution diagram. There's a lot going on there, and we use generators, right? And it's all in there in the calculation of PUE.
Thank you for asking about management. Everything, of course, is really done by the managers, and the teams are replaceable minions. That's how I see it, basically. No, I'm not totally sure how to take your question, but I'll try to answer it in one way. So I think one of the things that we really try to encourage is to push people out of their comfort zone, and Don and DLB can tell some of the pain that can cause, but we really weren't happy with what we were renting in terms of overall efficiency, and then also having actually done our servers for efficiency for a long time, that really led us into new ways of controlling air or controlling power, UPSs and so on. And so, one step leads to another. I think you need to be willing to take a little bit of risk, but I think with a great team, you can minimize that risk, and also with a great operations team who understands the value of taking some risk, right, in order to get gains. We were really able to balance that and have very reliable facilities, even though some things in there are maybe more novel. Some of the things actually help you make facilities more reliable by eliminating complexity. But as James, for example, has observed, in our kind of business, we're not a bank. We have large-scale internet services, and there's a certain redundancy based in the software itself. So it's actually easier to take some risks than if you have sort of single-homed traditional IT applications. Having said that, though, I think many of the concepts you use, and you're going to see this afternoon, isn't really something that only Google can do, right? Virtually every facility can actually get there. Maybe they can't get to 115 or something like that, but you should be able to get to 1.3, 1.4, in pretty much any place in the U.S. if you really apply these principles very well.
Thank you.
Hello, I'm Hank Kresak, and whoops.
Hold on a second. I think I have something to add to that. It's something Urs did, but without realizing, because it's in his nature. So the management has to allow crazy ideas in some ways. So, for example, when we came up with the single voltage power supply idea, a lot of people would say, hey, where can you buy motherboards that take only a single voltage? Okay, now you have to work the power supply vendors and the motherboard vendors at the same time to deliver that. But Urs said, go ahead, make it happen, right? So in terms of management, you have to be not conservative. You have to be willing to let your innovative minds to come up with strange things. And yes, I'll take that. and by the way, I'm moving into management.
All right, next question. Sorry.
Besides wondering about the car battery model you were using, a couple of questions. One on the raising the temperatures, if you could talk about where you ended up temperature-wise and your experiences with raising the temperatures. I assume we'll see the closed coupled cooling arrangements during the video tour.
Yes,
so
I'd like to defer that until this afternoon presentation. That's all about cooling, and so I don't.
So the temperature will get covered
yes,
there.
We'll
okay. And then the last question was variability. If the load, have you noticed when you were measuring PUE, if that changed much with the load of the data center during a day, during the hours of the day, or during the days of the week? Was there much change there?
Yeah, there is. That's not. It's captured to some degree if you look at that
scatter diagram,
detailed data on
yes.
the hourly. Yeah. So yeah, it does wax and wane with the ambient, right? We're tied to the ambient to some degree.
But did you see much of a swing? I mean, 10% or less?
10% on a PUE of 1.2.
It's not a lot.
Yeah, it's not a lot. So
right.
we could look at the numbers in more detail. But you saw it when it was in stable state. There was a kind of Brownian motion, little fluctuations there that are kind of related to weather.
Thank you.
Yeah, so the variation is actually, it was quite low. You'll see it on when we publish the slides, but let's say on E, where the average was, 112 or something like that, your typical variations, except for the spikes, are more like 0.02 or something like that. So fairly, 15% of the overhead, but in the whole PUE, actually very small.
Great. Hi, Dean Nelson with Sun Microsystems. First off, I want to say great job in sharing information. Applaud you guys for doing that. But I'm wondering about the change of heart over the last year or so. It's been really guarded, I think, for in the past. What really made you guys share this information out?
So let me answer that. I think that's actually simple. There's two simple answers there. One of them is we actually have been very, very busy and with a small team. And we were behind for a long time in terms of providing space to our company. And so that doesn't leave very much time for outward-facing kind of efforts, right? We really were under the gun for quite a while, and that really just precluded. Plus, we didn't actually know what the answer was because we changed our own answers sort of over time. So that was one thing that just very naturally held us back until about 2 years ago, 18 months or so. I think the second one is that we were really encouraged by the renewed industry, what we saw and so there was not people aren't actually interested in it. And then through lots of efforts, right, EPA, Green Grid, uptime, right, the POE becoming more popular, right, it really was clear that the time was there. And it took us a while, right? One of the reasons this workshop is now, not last fall, was really originally actually we had planned it for the fall, and the date just slipped because of time commitments on other projects. I think the key thing though here is, we're proud of the results that we have accomplished, of course, right? But the point here isn't so much like where we are, but I think the point really is where everyone could be, or virtually everyone, even for retrofits, right? You can really get very far with relatively simple, not super high tech, not super high dollar efforts. And I think it's really important to us that I think we're all in a space where the internet, uses lots of power, right? All the data centers should actually be efficient, and we should reduce our impact on the environment. I think the IT industry as a whole has a negative impact in a sense of carbon, right? We save carbon because of the benefits that all the computing brings, right? Like if you can look something up on the web rather than have to drive somewhere and or ship physical goods around, right? And instead you can replace it by virtual information that travels around. That actually saves a lot of carbon. There's been lots of study, but still we got to go minimize the footprint that we actually have. And then in these economic times, in many places there's really low-hanging fruit, especially if you're currently at a 2.0 of saving your company money in a relatively short time frame, right? 12 months. 18 months often, payback time for doing some simple optimizations of airflow or just turning off UPSs that you don't need and running at 70% UPS load instead of 30% UPS load, right? If your data center isn't full, and so really simple steps like that.
Sure. So last one word question: are you going to allow us to tour your data centers now?
No, only virtually.
Only virtually.
So, yeah, carbon footprint.
Had to ask.
Yeah. All right, we have time for actually.
Yeah,
one more question.
Danny Johnson of 365 Main. Was wondering with this server with the battery internal to those, have you been approached by any server manufacturers to actually start marketing these outside of the Google family?
We have been approached by many vendors in many different sectors, but since this is not where Google makes its money, so we did not explore that as a source of revenue for ourselves.
Sure. Now, do you expect this industry to grow where other manufacturers will maybe use this technology and use it maybe down the road?
I think the onboard UPS is actually a natural fit for many applications. We have a number of patents, some of them issued on the technology, but I think we'd be definitely willing to go license them to vendors, and that's one reason why we can be more public about it.
Fair enough.
All right, maybe one very last question, and then Andrew, if you could.
I'm Chuck with Verizon. Do all of your servers in all of those data centers use the battery on it?
Yes.
And has there been any maintenance issues with that or any fault?
Well, there's always maintenance if you have thousands of batteries, right? The PSU is able to monitor the battery, and also on the newer ones, actually able to test, right? So we can continuously test that
okay.
It's still working.
The final question is, you mentioned the 1% losses in the unit substations and in the PDUs. You're using something special for that, or and that seems to be a dramatically high percentage of efficiency?
So the losses, the question is the losses from the unit substation all the way to the IT
transformer losses.
Right. So the the scale, what I said was the scale of the power consumed across that chain from the measurement point to the IT gear was 1%, right? So it could be a large number still. Our observation is if you look at traditional UPS solutions versus what we did with the battery, that's where most of the losses occur. So we gained back a huge amount relative to industry standard that way.
And then to calculate the PU, you take the assumption of 99.9 at all the servers, and that's what you add back in as the losses at the servers?
We account for all the losses. That's a characterized result.
That's not measured.
Well, we do have meter, as you saw earlier. We have meters in all those chains where we had estimates. We actually metered them as well and calibrated our points. So on an ongoing basis, we meter and make sure our accuracy is where we think it is.
Okay, good. Thank you.
That's what allowed us to kind of get away from needing all these point measurements and all these servers at this time.
All right. Thanks very much, Chris and Ben. And I'm very happy to introduce Andrew Fanara today from the EPA, who has done, I think, an excellent job in really working with the industry and driving forward efficiency. So I'm looking forward to hearing your thoughts on what's in stock.
Great. Thank you very much. Is mic on? Can you hear me back there? Great. Well, thank you very much. Certainly appreciate the opportunity to be here. I know as I was listening to the presentation and watching the slides, my head was swimming with lots of questions to ask. And I'm certain there will be plenty of folks who will want to dissect that later on and lots of interesting dialogue about that. But got to sort of return to what my job is here, which was essentially to give maybe a little insight into what sorts of things might be happening next in the data center industry. And in fact, I was quite surprised and honored that Google would even ask me to prognosticate to some degree on what the future holds. And as many of you probably know, we try not to do that too much so, but at the same time, I have opinions like anybody else and would like to share with you a few things that are now on the cusp of happening or starting to happen now. The other thing that I think is just really challenging is, as you might have been watching the news, we're a little bit more busy in the government than we were in an EPA, than we were maybe a little while ago. And I'm not going to talk about things like cap and trade or the greenhouse gas reporting rule, which you might have heard and read about that EPA is preparing. There's a lot of things happening on the regulatory side of EPA and within Congress and within the administration and with a variety of stakeholders who are increasingly very, very interested in environmental and energy issues. And so given this very sort of challenging time, it's also very comforting to know that there has been a lot of progress made in a lot of areas. I think John Tuccillo has done a great job with the Green Grid. That will eventually be, and I think it was reflected in this presentation, that will eventually be something that will be a tremendous resource for the industry and for its customers longer term. And I think that I've watched the evolution from the early stages when it was a concept to a much more robust set of tools and ideas and really tangible steps and things people will be able to sink their teeth into and use. And I also want to thank Google because I think they made a number of good points in the presentation. But I think in general what Urs said at the end there, which was from the government's perspective, what we really want to see happen is we want to see the average data center get quite a bit better over time. We know that leading organizations who understand the benefits of doing all the things that have been mentioned here will continue to innovate and pursue a path which is more sustainable and more efficient. We know that they will do that, but really we have to get the rest of the herd to follow, and I think that they're, along with some of their competitors and partners, are blazing a path that I think will be very, very useful in the future. So just real quickly, I just wanted to mention a couple things that I've been thinking about and what I tried to touch on a little bit today. Really, the attention focus on data centers has really been maybe since 2003, 2004, it started to get people's attention. So relatively recent phenomenon. I think people have recognized that within these organizations, there are large opportunities for savings, and many of them are extremely cost effective. Not always, but relatively speaking, there are a lot of proverbial low fruit that's very, very cost effective, and we're seeing many, many organizations seize those opportunities. Clearly, one of the things at EPA, my colleagues at DOE, and my colleagues in other governments, and as well as industry stakeholders, have really tried to create a number of things to sort of break down some of the barriers to energy efficiency. And I was chatting with someone yesterday who was, really exasperated that he couldn't get one of his clients to embrace this, that for them, the client, it was still an afterthought, the thought about flexibility and sustainability and whatnot. And so I shared some of my secrets that help to get people off the dime, and we'll see what happens. But again, I think a lot has happened to try to break down those barriers, but a lot of work still needs to be done. And certainly the other thing that is apparent to me as I've spent time talking to folks is that data centers really truly are complex, and they don't sit alone on an island by themselves. They are part of a broader ecosystem. There are things, factors, and issues which are pressing down upon them, which are external in nature. Some of those, in fact, generated by the EPA and our attention that we're being paid or that we're paying to the data center industry. Some of them internal. There's some real innovation happening within the industries and within many of the stakeholder skunk works that seem to be having some really interesting results. But I can imagine that if you go back a decade and you would pull somebody ahead into the future and they were come here today, what we were talking about now would look completely alien to them just 10 years ago in terms of how we're talking about the issues inside of a data center. So it's been a relatively recent phenomenon. And the last thing I want to leave you with is that I think the fundamental long-term energy challenges have not changed. We've seen a decrease in the price of gasoline. Certainly that has provided some relief at a time of tremendous economic difficulties. But long-term, those challenges have not left us with all forms of energy, and every sector needs to do its part in the economy across the globe for us to meet the severe challenges that I think we're facing long-term. And really, sort of, if you think about that, none of this is not obvious probably to everyone here, but I just, sometimes think about it in sort of when you happen to turn on sort of the TV and you see that sci-fi movie that you've seen a dozen times on TNT, and it always sort of has the future where electricity sometimes is a sporadic sort of thing, and the world is living, or the quality of life is quite different than what we might expect in the future. And I guess what I just want to remind people about is that the future, I suppose, to a large degree, is going to be decided by the policies that we put in place now, particularly with respect to energy. We're not going to be able to change on a dime a large incumbent infrastructure that is here to stay for the foreseeable future, in spite of all the things that we want to continue to do to build clean energy sources. We have to get the productivity of our current infrastructure up, and efficiency is the way to do that. And I think there are lots of good examples in other industries that they've proven time and time again. So if we think about some of the heavy industries where energy is a really, really significant input into the equation to produce large amounts of whatever they may be producing, aluminum, chemicals, refining. If you've ever spent any time flipping through the pages of the Exxon annual report, I think you will see a ruthless dedication to efficiency in their operations. And I think that, this, by the way, is courtesy of my friends at the Department of Energy, so just some examples, but I think what you would see here is time and attention and decades being paid to energy management systems and processes which continually squeeze savings because they figure out a way to make it cost effective, and they know it's cost effective. Some of the examples here, some of the lessons here, I suppose, will trickle down into this industry and are probably already starting to be applied. And so I think the good news is that you're not alone in trying to overcome these many, many challenges, and many lessons have been learned, and we hope we can share within industries. So lots of other governments, my other colleagues in other countries, are starting to pay attention to data centers, just as they are for every economic sector, looking for the contributions from every sector to make to more sustainable energy policy and more development of clean energy, and overcoming the additional challenge of climate change, which is pressing down on us. And so there's activity in Canada, the US, the European Union, India, Australia now, Singapore and Japan are just, I think the majority of them. There's probably starting to be some others. There's a lot of interesting activity. My colleague Dale Sarter, who is also a colleague of Bill Schuette, who's here from Lawrence Berkeley National Labs, has been doing some work and some outreach, particularly in India and Singapore. Just came back from there for 2 weeks, trying to build capacity, trying to build contacts, trying to work with stakeholders to form partnerships to make sure that the Chinese and the Indians build the data centers of the future, not the current legacy systems that we find ourselves with. In Japan, my colleagues at METI just visited us in Washington, D.C., and they are very, very focused on this, putting real government money behind a green IT economy-wide project. One of the things that they think that they would like to investigate is a new metric that they're proposing. I literally just got this on Friday. I haven't had a chance to really drill down into this, but I think the point is that there is a lot of interest. In my experience, my Japanese colleagues, once they embrace a metric, they really tend to apply it with a lot of rigor and a lot of fortitude throughout the economy. We see this in the standards work that they've done for lots of products in Japan. So I think that Japan is one of the places where you will see a lot of activity. Here is just another slide to show how you can calculate DCBPE. I think it has, actually, I think the far side of the equation is DCIE, and then you have this piece over here, which I think is the previous slide, but essentially bits live in a building, live in the data center. How much energy do you need to bring the bits into the building, store them, move them around, expunge them, etc.? And I think that's what they're trying to get at. And I think John talked about the issue of useful work. What does that really mean? And this is, I think, the Japanese take on this. And so our plan is, if you've got thoughts on this, really John Tuccillo, who's been working very closely with our Japanese colleagues and with Japanese members of the Green Grid, is going to be gathering up some of the comments. I believe, John, we agreed on that. And so if you've got some thoughts here, he will put those together, share them with our Japanese colleagues, and try to get a dialogue going about that. But you can see that they're already looking beyond PUE, but clearly they would like some feedback on this. Sort of extending their idea a little bit, clearly the broader ecosystem outside of the data center extends to many things in our living rooms and our offices, which are digital in nature and which increasingly we rely upon. This broad network of products increasingly is an opportunity for efficiency. At the same time, we know that there are opportunities to use those products to displace the old ways of doing things, which frankly are probably fairly carbon intensive and probably carry with them in the future some risk associated with doing things in the old way as opposed to a new way. So, not surprisingly, the Japanese are also thinking about this with a large IT industry and technology, many technology companies in Japan. This is the way they sort of describe the potential for information technology to have an impact on the future of energy and climate. They describe it as green IT, is the green of IT. I suppose that's the footprint, plus what can be made more green by information technology. I suppose they would throw in their telecommunications as well. And so they've made some projections. They've done some work. It's interesting that this is starting to happen. More study is necessary. In the OECD, which is studying this issue as well, there's actually a conference in Denmark, the second follow-on conference from one that happened in May, to study precisely this issue. Some of your companies that are represented here will be actually at that meeting. They're really trying to study, quantify, and provide more analytical rigor about what is really the potential of IT to impact the future way we use energy and the positive benefits that might accrue to the environment. More study is needed before the government can rubber stamp that as something that would be a good climate change strategy to mitigate climate change. So work is being done there, and in fact, the work that's being done in Denmark this May will eventually inform the next conference on the parties, which is in, I think I want to say November, December, which is really the next big climate change confab. Just some additional data here about the contribution. All these slides will no doubt be made available. People can study them at a later date. Here in the States, the Digital Energy Solutions campaign is underway. It's a fairly new effort. These are some of the founding members. I think some obvious names there. I think they're beginning to look at things to try to make those who make public policy, decision makers in that realm, to try to inform them of the benefits of IT and to try to find opportunities where partnerships can actually set up pilots to actually demonstrate some of the real world potential. So for example, actually not related to this, but a different example that is being discussed by some other companies would be the idea that potentially maybe data centers could be offsets in a cap and trade regime. A lot more work needs to be done to sort of flush that idea out, but people are beginning to discuss these ideas. And of course, as you can imagine, at least the initial paper that I read had quite a bit of complexity behind it, because it's not as simple as one might think when you begin to pull back the layers of the onion and you try to figure out what the value of something like that might be in a regulatory regime. It's challenging, but it's an interesting concept and one that you'll probably hear more about in the coming future. So what else is going on in the public sector? Well, I didn't want this presentation to be one long advertisement for my program, as many of you have seen my presentations and know that I do that from time to time. But we are trying to do a specification for servers. I think one of the themes that hopefully will be discussed here today, and I think has already been raised, is that there truly are a lot of opportunities to improve the efficiency of computing. Infrastructure is one thing, efficiency of computing is another. Our toe into the water for servers is just that. It's a beachhead. It's an attempt to begin to change the dialogue around this issue. We have a long ways to go, particularly many of you have probably actually seen and read my specification and know we have a long ways to go, that it's an imperfect animal, and we are looking forward to continuing the dialogue with the industry. We are also doing a data center benchmarking effort. My colleague Mike Zatz at EPA has been busily collecting data. That's been going quite well. Not surprisingly, we had about 250 data centers raise their hand and say we'd love to contribute data. Only about half said we actually have the data, or we now figure out how to do it, etc. I suppose if we were to, I suppose we're not surprised by that, but I think the good news is we do have enough data to go forward to try to do for data centers what we've done for supermarkets, warehouses, hospitals all across this country. We've got about 80,000 buildings benchmarked with using our Energy Star tools. Many of those are Energy Star certified, and as a result, those buildings have greater value because the means to manage that building, the utilities, etc., is less. The cash flow is better for the people who own and operate the buildings, and thus it is a more valuable piece of real estate, and I think that's exciting, and we want to do more of that. So we're moving ahead there. Paul Shine, with a lot of the work that's being done on his behalf by the Lawrence Berkeley Labs, is clearly doing a lot of work around Save Energy Now. The Federal Energy Management Program is doing a lot of work in the federal government to try to get the federal data centers to move in the right direction. That's proving to be a significant challenge, but at the same time, we expected that, and we're responding as such. The DC Pro tool is beyond its first couple of versions, and I think that that's shaping up to be a great free tool that people can use in their analysis. We're looking forward to more applications of that. Paul's also doing his professional certification, or developing his professional certification program. We need to get more qualified people out there in the field who are in possession of the skills and perspective to be able to give good advice to people who want to take the first step to tackling these energy challenges. We definitely want to make sure that people that hang a shingle out are not giving bad advice. And so, in my experience, there's a lot of engineering talent out there, and this is, I think, a good professional certification that they can have to bolster their credentials. Also, ISO 50001 new standards should be out, I I'm told 2011. Essentially, that's an energy management process standard, and EPA, DOE sit on the technical advisory group in the U.S., but clearly this is something that we think data centers could shoot for in the future. It will be a good way to show that your facility, in addition to other metrics or data that you may have, is world-class. And so that's coming down the pipe. What government presentation we have this thing called the stimulus, or AKA the stimulus plan, the American Recovery Reinvestment Act. Seems like every presentation probably in the government talks about ARRA in some form or another, because it's a massive kick in the pants to get things going. And there is actually some activity happening there. I'll have another slide on that. And there's some interesting things happening at the California Energy Commission with respect to the U.S. Green Buildings Council. But let's return for a second, if we could, to the stimulus bill. So clearly there were a lot of things that were funded in the stimulus bill. Some of those things energy related. It turns out IDC did an analysis. They actually think that the roughly $40 billion in investment that will be made over roughly, I think, the next 18 months or so, 2 years probably at the most, will probably leverage another 70 to 100 billion in technology spending. Technology, I suppose there's a little bit of a blend with technology related to developments of new forms of energy, but nonetheless, quite a bit of stimulus there. The Department of Energy is responsible for sort of the application administrative process to dole out the money. And generally, the strategy is this money has to be provided to state and local governments, because they'll be the best ones who can put in place those projects which are ready to go, which will have the most impact in the very, very near term. So the deadline is actually approaching very soon. I've actually chatted with also a number of utilities who are working in conjunction with state and local governments to try to figure out what are the projects we can get going. I suppose many of those projects might be building energy efficiency projects. And I don't want to go out on a limb here, but I suppose that if you've got a commercial office building or some sort of commercial building, if it's got a data center in it or some sort of computer room, and that gets more efficient, that makes the entire building more efficient. And so you can put two and two together and see where maybe some of this money might actually spill down or trickle over to things related to data center projects. So let's hope for that. So there's a big focus on energy efficiency because it is the cheapest, cleanest, quickest thing we can be doing right now, hands down. And so one of the things that we're doing with the state and local governments is we're saying if you want to put forward the best package and probably do so in a way that really demonstrates that you're ready to go, you really should rely on some of the tools that already exist, like Portfolio Manager that we use in the Energy Star Buildings program, that can be a tool to really help you jumpstart your projects, can help you identify better, most cost-effective projects, that can help you quantify the actual savings and be able to report that in a really solid way. That's very, very important. And of course, you can find more information about this at energystar.gov/government. One interesting development in the state and local realm is that New York City has just, I think, passed a new, I don't know if they call it a law necessarily. I guess I should find that out. But an ordinance maybe, but certainly a law within the city of New York that says if you've got a building bigger than 50,000 feet, you have to benchmark it every year and report and disclose if your numbers are going down or going up. And as you can imagine, going down is probably good. Going up in terms of your energy use is probably not so good in an era of more expensive energy. And so this is something that I think we will see more of. I understand that a version of this or some version of this is happening in Tokyo, but certainly those will not be the only two cities where we see this happening. It's a harbinger of the future. So the U.S. Green Buildings Council, they've begun to take a look at whether or not it makes sense for them to update the criteria for their data center specification. Clearly, the USGBC and the LEED program has had a tremendous influence on the commercial building sector, and we certainly think that that is phenomenal, and they're continuing to do great work, not only in the U.S., but they now have a footprint in about 80 different countries. So with some funding from the CEC, a proposal was put together. Some of you in the room today contributed to that proposal, and as I understand, it's being entertained by the USGBC, and I think that's an interesting direction. I've seen the proposal. It is much more expansive in terms of the things that it addresses, everything from water to electricity to many other factors which have to be taken into consideration. Utilities are getting increasingly active. Many of you have probably seen Mark Branfit's presentation from PG&E, but he's certainly not the only one at a utility that is working with and partnering with its customers to try to unlock some of the energy efficiency potential. Clearly, utilities in the future need to do more about the grid, and unfortunately, we're at a time where there is an unprecedented amount of capital that needs to be invested in the grid, at a time when capital is very hard to come by. And we probably need upwards of $1 trillion over the next 10 years. Don't know where that money is going to come from. I think the grid ultimately will become more flexible, and we'll probably get a lot more out of it once we start to see some more investments made through the smart grid, but that will take time. And in the meantime, there are spots of congestion and concerns on the part of utilities who have to dampen certainly peak loads at a minimum. And so in my old area of DC in Northern Virginia, Virginia Power, or Dominion Power, excuse me, feels like as much as 10% of future energy consumption will be from all of the data centers that have clustered around Northern Virginia. Lots of them there, and that is not an unusual phenomenon. Excuse me. Here's just an example of some of the members, I think all the members of Mark Branfit's Information Technology Energy Efficiency Coalition. There are a few from the East, the majority of them from the West, and I think that is not atypical from the standpoint that many things get created here and then find their way going east. I did want to highlight PG&E because the last presentation that I saw Mark Branfit give at the Green Grid, he mentioned what I thought was a very interesting point, which was he's not only interested, frankly, in what you can do inside of your data center to make it more efficient, but if you could potentially prove to him that you've got a project where you're using the data center, or the data center is a tool to impact something or to put in place some set of activities which will lessen energy consumption. Let's just say, for example, the one that everybody points to, doing some form of teleworking, working from home. If you had to expand or your data center to do that, to put in place the infrastructure to make that happen, and there were demonstrable benefits for that that flowed in some way to the utility, he'd be willing to take a look at that as an example or a possibility of potential funding. So there are lots of interesting things there. I'm not clearly doing it nearly enough justice in terms of the way he explained it, but I think things are getting more interesting in terms of what's possible in the future. NYSERDA, if you want to talk about grid congestion, the Northeast is the place to go. They have just kicked off their data center energy program. Here are just a couple of the highlights of some of the things that they are doing. I think that they are going to do an update at the Uptime event. I believe it's on the 15th, 10 a.m. if I remember. But there's lots of I think energy behind this effort. A lot of I think real dollars in place to help people tackle these problems, and it's an interesting development. I think that they have learned from what some of the other utilities have done and put in place a good program. Sandy Wang at NYSERDA is the person that you would contact if you have follow-up questions. So I just want to draw to a close, and I think that one of the things that I've heard about recently, which I thought was a very, very interesting partnership between Skanska and eBay. I think in eBay, you've got a very motivated customer, large user of data centers, clearly, that is very interested in, frankly, trying to build these data centers of the future, not data centers of legacy data centers, clearly. And I think that it's a recognition that the entire sector has gotten a lot more complex, frankly. It's a lot more challenging, I suppose, now to run a data center, just given all the things that are coming together to that are coming to sort of bring to bear on data center operators and companies that own data centers. And so given this sort of complexity and the pressures, I mean, when you're building a new data center, you've got to pick a site. It's got to be the right site. It's got to be properly built. It's actually has to work when you get it commissioned. It's actually got to hopefully come in under budget. And it hopefully has to provide the types of services that people actually want and expect. And so it's very challenging. And I think most people built data centers and they thought, well, gosh, we've got to make this building last 15, 20, 25 years. But I think this partnership is really trying to think of a different approach and strategy. And I can't nearly do it justice. And Olivier is here from eBay. He'll be happy to talk about this more. But what I think they're trying to do is trying to break down the siloed stages that exist in designing, building, commissioning, and operating a data center to bring more of that analysis forward so they can build a data center that might have a 20-year life, but frankly, maybe it will have 4 or 5-year phases that will be much more flexible and adaptable and hopefully a lot more cost effective. And they use the term just-in-time data centers that might actually be more modular in nature. When they said just-in-time, I thought, that's a great idea. I really think that I get that, and I understand that why build a large facility when you can build a small one for what you need now and expand later in the future. And I think for me, frankly, it's a function of looking at this very innovative industry. Obviously, you're builders of some of the most high-tech buildings in the world, and I think it's this sort of effort which, for me, makes me hopeful that the lessons learned in other industries that can be applied here, and frankly, some of these new partnerships, I think are really critically important, and in fact, may spill over and affect the wider building community. And if that's possible, certainly that will be a tremendous benefit to, and credit to all of you. The last thing I would want to say is that we do have a water crisis here in the United States, and the things that we're discussing to a great degree right now about energy, in fact, might come to bear with respect to water. And no doubt, folks in California are very, very knowledgeable and aware of this particular issue. It's probably worse in many respects in other parts of the world. So this issue is going to provide more and more complexity when designing, building, and managing facilities. I think you might have to think of a day when water is not an option anywhere in the data center. It may be as draconian as that, and that's something you might have to consider. And right now we've got probably 36 out of 50 states that would report serious problems, maybe not necessarily crisis, but very, very serious problems. And we've got to contemplate that going forward. So on that note, just a couple of final takeaways. Clearly, what I've heard in many of the conferences and discussions that I've gone to is people are told, don't hunker down, try to invest now because you will, in whether it's energy efficiency or other innovations, it will help you come out of this tough economic situation that we're facing stronger and better prepared to be competitive in the future. We all know intuitively that large users of energy are being paid more attention to. Data centers are no exception. And also there's the flip side of that. The ICT industry, data centers in large part, have a tremendous amount of potential. But before we can get there and really, I think, sort of extract that potential and leverage it, we have to do a bit more studying. I think we're looking forward as the government to working with you to better understand the implications for broader deployment of IT more broadly in the economy and what it can do to tackle the twin challenges of energy supply and building more clean, sustainable energy supplies in the future, and also climate change. Clearly, the industry is coming to grips with how to better refine and understand its management processes with respect to energy. You're seeing some of that clearly here in the presentations that have already been done. That's very, very promising, and I look forward to more of that happening in the future so that we can be more like the chemical and refining industry, I suppose. And clearly the other thing that I'm very interested in is trying to drive more efficiency in computing. Yes, the infrastructure is critical and important, and a lot of work has been done there, but I think we've only begun to scratch the surface in terms of how to make computing more efficient from, yes, the power supplies, which a more efficient power supply, as we know, makes your server or other IT system more efficient no matter how you use it, But clearly the big opportunity is to change the way in which you use it, to do the computing differently and more dynamically. That's probably where the huge potential is longer term. So the last thing I want to say is, I don't want to be a lone voice in the world or in the wind. I don't think I am. I think many people are saying the same things that I'm saying. We need more partnerships. We need to be more innovative, and we need to keep working hard, which I know all of you are by virtue of the fact that we, see each other from time to time, and all of us look fairly tired and exhausted. So I guess that's not such a bad thing. So at any rate, I, again, want to really thank Google for the invitation. I really appreciate it and look forward to talking to you more. Thank you. Maybe a quick question or two?
Yes.
Great.
So thank you, Andrew. Questions? We have about 5 minutes for questions. You can also answer your tax questions, I'm sure.
Right. So, well, we may be. Oh, wait, I think we have one. Okay,
Right.
great.
Hi, I'm John from the Uptime Institute.
Hey,
I
John.
was wondering if you could say, you mentioned something about potentially data centers being counted as offsets in a cap and trade scheme, but you also said that was kind of far out. Tell us more about that.
Sure. Well, as you can imagine, as discussions about how to tackle climate change have gone from rhetoric to more serious discussion in the last couple of years, not surprisingly, the issue of offsets in general have been discussed as a means to operate under a cap and trade regime. And this is not the suitable time to go into the particulars of cap and trade. Nonetheless, I think what I think has been advanced as a prototype idea is that potentially data centers could be leveraged in such a way to do work more efficiently than would be done otherwise. If that could be verified with a rigorous protocol, maybe it would qualify as just as offsets might be done in other areas, which might be carbon sinks, like planting more trees. If there's a measurable sort of impact that can be verified and can be creative, that wouldn't have happened otherwise, then maybe some form of credit or something could come to that. It's obviously this is a prototype idea that hasn't really been thoroughly debated yet, but I think you'll probably see more discussion of that.
Right. I guess that's what my question was. It was kind of more, what is the status of the debate and the status of trying to get this type of protocol hashed out? Is that completely nascent or an idea that someone overheard someone throw out, or is it in the works?
No, it's in the works, and I think if you'd like to learn a little bit more about that, I suggest you follow up with Steve Harper at Intel. He's been doing some thinking on this with some other folks in the industry, and I think that they're discussing this in greater depth. And clearly, I think Steve would tell you a lot more work has to be done, but it's not surprisingly things have come up like this, and I think that's a very good sign.
Thanks.
You're welcome. Make lunch.
All right. Thanks very much.
Great.
Andrew. So we're going to be back here at 1 o'clock. The cafe that we're going to is called Cafe 14. It's in building 1400. You go out here and then all the way straight down there. There is a room reserved for us there, but if you prefer, you can also take your lunch outside and eat on a terrace. But don't forget to be back at 1 o'clock for our resumption of the sessions. Thank you.